converting formulas that are polar curves into Cartesian and converting from Cartesian into polar. So that's kind of the first part of today. We'll see how quickly we go through that, whether we get to the next bit. So I'm going to pick, I don't know what 17 looks like, but hopefully I've not done it before. Yeah, I did do 17 before. So let's pick 20. And in question 20, you are given the equation of a polar curve, and it's in the form 9 over 1 plus 3 the sine of theta. Yeah, evidently it's a polar car. Did you see that? No, it's a polar cooler now. No, good luck reading the captions. Anyway, this is the guy that we've got, and we want to turn this into x's and y's. If it's possible, you should try and do it as y equals, but sometimes you can't. And at least if you turn everything into x's and y's, you are good to go. So I know that r is the square root of x squared plus y squared. And I'm not going to go that way. I'm going to cross multiply. And that's r 1 plus 3 sine theta equals n. And the reason I'm doing that is I don't like fractions, because fractions tend to make things horrible. Now I'm going to do r plus 3r sine theta equals 9. And I know that r sine theta, right? R sine theta is y. So this becomes 3y equals 9. Now I'll turn that guy into x squared plus y squared plus 3y equals 9. And I certainly have converted everything into x's and y's, but I haven't done it in a way that would give us at least a fighting chance of writing it as y equals. So I'm going to see if I can make this look prettier. So I'm going to subtract 3y from both sides, and then I'm going to square both sides. And now I'm going to have x squared plus y squared, 81, take away 54y plus 9y squared. And I think I'm reaching the end of the line here. So what can I do? 81, take away an x squared, take away a 54y plus an 8y squared. And I guess there comes a point in time where I've done the best I could. I don't think I can turn that into a y equals y. It really doesn't have any great shape to it. But at least I get rid of the square roots, and that was something. Now the next one, question 21, is y equals 4x squared. And y can be rewritten. Oh, we're doing the wrong questions here. Yeah. This can be written as 3 sine theta. And this can be written as 4 times r cos theta. I'm getting deja vu in this one. Did I do that one yesterday? So I'm pausing. Oh, okay. When you're doing this way around, you want to try and write it as r equals if you can. Okay, what can I do to both sides to make this prettier? Any ideas? What could I do to both sides to simplify this?
Divide by an R.
Yeah. Now, since I want R on its own, I'm going to divide both sides by 4 cos squares. And that's good. And I like the R to go first. So this is really only cosmetic. And that's good. But we have a rule. And the rule is avoid fractions if you possibly can. So I'm going to rewrite this as 1/4 sine theta over cosine theta times 1 over cosine theta. And that's going to get me 1/4. That guy and that guy, I'm going to change into something else. Okay, what does a sine theta over cosine theta get me?
Tangent.
And what will a 1 over cosine get me?
Secant.
And we are finished. So you try to get it to be R equals, and you try and get rid of fractions. In this case, we managed to succeed in both cases. They are kind of random, kind of jumping around here, but that's fine. Let's try 22. Well, y equals 5. Y gets replaced by r sine theta. So this one should be a pretty straightforward one. Remember, one of my 2 goals is to get r on its own. So if I wanted to get r on its own, what would I do to both sides?
Divide by sine theta.
And the second thing, if it's possible, shouldn't I try and get rid of fractions? So what would be another way of saying 5 over sine theta?
5 times
5 times
Cosecant.
cosecant.
That's the guy. It's hard sometimes to remember whether it's called a secant or a cosecant, right? Because they sound very similar as well. That's the end of that one. We have r equals 5 cosecant theta. So this one I'm going to have to eventually turn into x's and y's, right? We've got polar, we want the other version. I'm going to have to do something here. Nowhere in this list do I have anything with cosecant theta in it, right? So if I leave it as cosecant theta, I'm going to be in trouble. But I can change it into this guy, which agree this is the same as that. Now, if I cross multiply, I get r sine theta equals 5. And remember, the goal here is to turn things into x's and y's. What does r sine theta get?
Y.
And in case you haven't noticed, y equals 5 gets you this. This gets you y equals 5. Do you see that they're actually, you know, the same question in 2 different directions? It's kind of cool. Did you notice? If you started with 5, this is its polar. If you started with this polar, don't you get back to that? Which kind of you would expect, wouldn't you? I mean, they're just 2 different ways of representing, in this case, a straight line. And where shall I go next? Ooh, there's some cool ones. This question looks harmless, but it does involve us having to do a piece of algebra that doesn't come to mind right away. If I look over here in particular, right, because I'm going to be turning these into x's and y's, an x can be replaced by this, right? A y can get replaced by this. A theta could get replaced by that. That's probably never going to happen, or virtually never. And the r could get replaced by this. Now I'm looking at this question. If you jumped in too early, you'd be in trouble. If you say, oh, okay, square root of x squared plus y squared equals 4, oh, I'm in trouble, right? There isn't a cosine theta on its own over here. So I am going to do multiply both sides by r. Would you agree that's okay as long as you do it to both sides? Now, that guy is no longer that difficult to deal with. Isn't that r cos theta just an x? So 4r cos theta is that. And isn't this guy x squared plus y squared? And if you want to make it look pretty, how about x squared plus 4x plus y squared equals 0?
Wouldn't it be minus 4x, not plus 4x?
Yes, it would. Or I could do a y squared is 4x minus x squared, and a y is the square root of 4x minus x squared. Yeah, I could have done that as well, I guess. You agree that and that are the same, they're just mathematical. Technically, plus minus, now they're the same. Next fella, r equals 4 sine theta, take away cosine theta. Okay, we're going to turn this guy into x's and y's. Any ideas what you could do? What would be my next line of work? And
Cross multiply.
yeah, if nobody got it, I was going to do that, but you got it without me even doing that. So if you go this way, you get r times the sine of theta, take away the cosine of theta, equals 4. And then you distribute the r. And r sine theta is x, and r cosine theta is y. Have you noticed in all these questions, you don't want a sine theta or a cosine theta to be on its own? Don't you want it to be an r sine theta or an r cos theta? So if it doesn't have one, multiply both sides by r so that it gets one, or cross multiply so it gets one. But whatever it is, try and get an r sine theta and an r cosine theta, because if you don't, you just not be able to finish it. 27 is too obvious. Ooh, 28. R squared is 3 tan theta. I do not need to do anything too clever here. In fact, I'm really good to go. I should be able to turn everything into x and y without any other algebra. So r squared is x squared plus y squared, agreed?
Mm-hmm.
So that goes here. And that is interesting, but that's more useful. The tan of theta is y over x. So won't this just be 3y over x? And if you wanted to make it look a little bit prettier, you would do a cross multiply. And then x cubed plus xy squared is 3y. And normally in these kinds of questions, you get all the variables to be together. So there would be my answer. But there are other combinations. Just looking at WebAssign actually said that's okay.
I have a question.
Yes.
So for 28, what exactly is it asking us to do?
Oh, it's asking us to take the equation that's written in polar form and convert it into an equation of the same curve using Cartesian form. So we're basically taking a formula that has r and theta in it and turning it into an equivalent formula that has x's and y's in it.
Thank you.
Now, question 29 doesn't have an r in it, but nonetheless, we're still going to be able to convert it. Okay. Just looking at that very simple expression, there's not a lot going on there. It's not really written in a very friendly format for what we need, right? It's got a secant in it, right? We don't use secants. So how could I rewrite secant?
1 over cosine.
No, so that'll
Yeah.
equal cosine equals 1 over 2.
Let's see. Yeah, or 2 cosine theta equals 1, and cosine theta is 1 over 2, right? We're kind of there, but we still have a problem. Don't we have a cosine theta? And we don't like that. Don't we need an r cosine theta?
Can't you
So how
multiply
would-
both sides by r?
That's the strategy. You're getting it. Now, once you got to that point, this fella here is x, and this guy here is an ugly x squared plus y squared deal, right? WebAssign looks to me like it's very lenient. In other words, if you wrote that in WebAssign, it would say, okay. I don't kind of really like that. So I would multiply both sides by 2. Then I would square both sides. And then I would subtract an x squared from both sides and subtract the y squared from both sides. I think that looks prettier, but maybe that's just me. It's equivalent.
Yeah, I think WebAssign gave me a different question for 29. They gave me secant equals the square root of 2, which changed everything about this equation.
Did
Well,
it
how
not
I had to
even
go
look?
about this.
Oh, yeah, maybe. Yeah, it could make.
Because it found it allowed me to change theta to pi over 4. So the problem ended up being y equals plus or minus x.
Interesting. Oh, yeah, if you rearrange this one, you would get y squared equals 3x squared, which would get you y plus or minus root 3 over x. God, there's a lot of different versions of that same curve, isn't there? Depends on how you want to deal with it. Does it take that version?
Oh yeah, it did for me, but it was because I had to use the unit square because it said secant equals square root of 2, and then that later on changes the to cosine equals 2 over, well, square root of 2 over 2, which was
Gotcha.
pi over 4, and then
Right. And
just
then
kept going down.
that gives you an angle, and you get y equals 5.4.
Yeah, plus or
y
minus
equals
x.
x. Yeah.
Mm-hmm.
And it took that one as well. Well, it looks like it's taking lots of different versions of x's and y's. Cassandra, did you have a question there?
Can we not treat the cosine of theta as x?
You need an r cosine theta to get an x. So not just cosine on its own. It needs to be r cosine. Then you can treat it like an x.
Okay.
I think we've pretty much covered all the good stuff. I'm doing a quick scan in case there's anything obvious.
I guess I had a question
Yeah.
from yesterday.
Mhm.
For the
Yeah.
second half of 30, of question 30, what is it asking me to do? Is it asking me to use the numbers he gave before and convert it, or?
But let me show you, because I think sometimes they make a meal of it. So this is the question where you watch a little movie and then you do stuff on it, those kind of things. I believe it's that question, right?
Oh yes.
Okay, here it is here. So they have a kind of grid system, and there's all the information that we know about. We've used it. And is it this piece here you're talking about?
Okay, yeah. I guess I was trying to use the values he gave me before and convert it, but
Right.
yeah, that makes
So
sense.
you're just basically taking an AB guy and moving it around to see where these guys would go. Have you noticed that it's basically the same points, but plus or minus in different combinations? Each one is from a different quadrant, I think. It looks like it is anyway.
Okay, now that makes sense.
Good. That is the end of that particular topic. So we're now moving on to our next topic. So we're actually ahead of the game. What do I mean by that? We're actually further along than we needed to be if we wanted to finish on time. Now that isn't really a big deal, because doesn't that just mean we can have more time to revise for the final? So I'm not too, well, if I'm going to have a problem, that's the problem I want, right? To finish early than, you know, rush at the end. So I'm okay with that. So what we're going to look at next is sketching polar curves. Now, suppose I had a polar curve, r equals typically, and I don't think you can see what I'm
We
writing.
can't see your screen.
Yeah, I thought that. So suppose I had that guy, right? And I'd like to know what it sketches. So a lot of the questions you're going to get is, here is this curve, and then they give you 4 pictures, and you have to pick the right one. Now, the good news is you're not going to do it by hand. You're actually going to do it by a version of Desmos. And this is a special version of Desmos that does polar. So I'm going to go right over in a few seconds because the thing's taking too long to set up. And here we are. Let's close that guy and let's go into Desmos. Now, you see that is not the usual X and Y. Do you see all those little concentric rings? That's called polar paper. It's used, well, let's get rid of that guy, right? It's used to help you plot polar coordinates. So for instance, see if someone went and said to me, 2 comma pi upon 6, I'd go to the circle of radius 2, I'd find a projection line that was pi upon 6, and I'd go there. You see where my mouse is? That's where I would put it. So this is what polar graph paper looks like, rather than, you know, Cartesian, which is square grids, right? This is polar. Now, if you want to type in or use it, let's do r equals 3 cos theta. And I believe if you just type in the word theta, you get theta. And it helps when you hit the right keys on the keyboard. God, I get big fat fingers. It's a circle that's off-centered. Do you see that? Now, can you imagine your 4 pictures might be a circle center of the origin, maybe a squiggly line, and so on. Now, let's change one piece of that puzzle. I'm going to put a 2 there. Do you think that's going to make a big difference? Let's find out. Whoa, it made a big difference. Would you agree that don't look like a circle slightly off center, right? So you can, I mean, I love this bit because I just love graphical things anyway, but you can have a lot of fun with these, can you? So I'm going to find the next one. This is a boring one, but it does prove things to you. What do you think r equals 3 would be? So if you plotted all the points who were 3 away from the origin at any angle you like, what would that look like?
It would just be a circle at 3.
There you go. Cool. By the way, that's question 2. How about 3 plus 3 sine? I don't want to hit the theta because the picture will appear. What do you think that would look like? Well, watch. They even have names for some of these. I think that particular one's called the cardioid. That was question 3. That's boring. That's the same one.
How did you get to the polar, Desmond?
Oh, I've put it in Canvas, and
Oh,
you've now got a link there so you can get it yourself. That's boring. Yeah, this might be interesting. How hard is it to spell theta? It's just a cardioid going the other direction. This one is interesting. R equals theta. Cool. You see that? Now, if you wanted to, you can change the range of theta. So you don't want to plot all of them. You can say theta to 2 pi. Do you see that all you get then is the piece of the curve from 0 to 2 pi? There's another card. Oh, here is a sequence of functions. Right, that's sine theta. Little green guy, nothing. Zoom in a little bit. There we go. And now I'm going to do the sine of 2 theta. And now I'm going to do the sine of 3 theta. And one more, although it's getting really messy, I'll do the sine of 4 theta. Right. Well, apart from the fact, is that not pretty? Yeah. Now, there is a connection between, let me make those guys go away. There is a connection between how many thetas you got, 2 theta, 3 theta, and 4 theta, and how many of those loops, I think they're called petals officially, right? How many of the petals you get. So if you do 2 theta and you do 4 theta, do you notice the connection? Don't you get twice as many petals as the value? So if I typed in sine of 20 theta, wouldn't I get 40 petals, right? Now that's what the even ones look like. Now if you do, well, one's a special case, but one is like one petal, right? One big fat petal, right? Think of the circle as being a petal. And if you do this guy, you get 3 petals. So the next one I'm about to do is going to be 5 theta. How many petals do you think it's going to have?
5.
And let's see if you're right. Yep. So can you imagine if you're playing about with this, isn't there some kind of structure? It's not like every shape's totally different. What do you think? Let's kill these guys off. What do you think would happen if I did a cosine of 4 theta? How many petals?
I would say 4 because I want to think it's different than sine.
Why can't I see that answer?
You gotta click on
What?
would it be 8?
No, I put an extra space in for some reason. Right, click off. Why is that not working?
It's not filled in on the left side.
You need to fill in the bubble on the left side underneath the 15. Right
not sure.
over to the left of the equation itself.
Oh, there's a thing saying
Yeah.
50. Whoa, there we go. 1, 2, 3, 4, 5, 6, 7, 8. Now
Ooh,
I'm
that's wrong.
killing. But it could have been what you said. There's a lot of logic that it might have equally have been that. Now I'm about to type in the sine of 4 theta, right? So I'm matching a 4 theta with another 4 theta. Do you think that this is going to have 8 petals? Yeah, we've done that. Do you think it's going to be the 8 petals in the same place? Or are they going to be in a different place?
I think it's gonna be slightly rotated.
I think you're right. Now, what would happen if I put in, well, let's copy this one so we have both. So I've got this one. And I stick a number like 2 here. That's what the cosine of 4 theta looks like. What do you
Are the
think
petals gonna
2?
get longer?
I think they are.
Also, it is similar with like the period and amplitude of the Cartesian.
It is in a way, isn't it? Like amplitude is how far the petals go, right? And period is like how many petals you get in one rotation. Yeah, they're kind of similar. And I'm just going through, they're boring, boring, done that one.
I don't know if you answered this already, but why,
Huh?
like, when you have even numbers, it doubles, but when you have odd numbers, it's just the odd number?
I haven't said it because I don't know is the short answer. There's probably a good mathematical reason for it, but I can't think of it. It just is. But I've just saw something that I don't have a good reason for it. Somebody more intelligent than I probably would. I'm going to change this to 1/2, not that 1/2. Okay, I'll probably need a bracket then. 1/2, and I'm about to type in theta. Any guesses what that's going to look like?
Is
I
it
don't
gonna,
blame you. Go for it.
Just 2 petals.
It's gonna look like a sideways heart.
It's going to actually look like that guy. And I wasn't predicting that because I don't know what it was going to look like until it happened. So let's put this one back in so we can compare them. Do you see what a little change to an equation can do to the thing? The green one on the right is the cosine of theta. The red, the look thing, I don't know what else you would call it, right? Looks like that. They're just fascinating to study. And I'm sure there's absolutely no practical use to most of this, but it's still fun. So I'm going to try and put that 2 is going to become a 3rd. So I'm making a prediction that could equally be wrong, but I think you're going to get one of those 2 intersecting thingy bobs, but I think it's going to be 3 intersecting circles with some little bubbly things going on in the middle. And I have no idea. And we're about to find out. And I was wrong. That's fascinating. Why it does that, haven't a clue. Same reason why I don't know why cos theta does this, but cosine, 2 theta does that. So that's kind of us for today. What are you going to have to do in this second section? Are you looking at the questions right now? Is that what you can see on the screen? No.
Yes.
Okay.
Yes.
Oh,
yes,
you
we
can
can see your questions.
Okay.
Yes.
All right, let's kick this off then. Essentially, you've got this guy, and there's 4 pictures, and I can't remember which. Well, there's 6 pictures. Okay, so it's one of those 6, and you're going to say if it is picture 4. Can you imagine how much fun and how quick this section is going to go? right? If you wanted to do r equals 3, wouldn't you get, I would say picture 3, and you just say 3. Now, question 6, pick the right graph. So let's say it's that one. And there's the guy that we were doing today. Can you see that some of the questions you're going to rewrite them in rectangular coordinates? That just means, you know, x squared plus y squared minus 2xy equals 10, right? That kind of x and y jumble. So you're going to get more practice at doing that. And for the most part, isn't it just pick a picture? That is so cool. Well, for me, that's cool. For some of you, it might be it's boring, but I think it's fun. Oh, I just had a thought. Let's clear all this out of the way. I'm going to pick weird. I'm going to see if I can break this guy. There's r theta. Cosine of theta plus 5 sine of theta. I'll have to fix some of these if it's not worked. Take away a theta. Yeah. Oh. Oh, am I an artist or what? Is that not cool? You know, all I need to do is fill them in with color, stick them on a wallpaper, and I've got a new job, right? Or can you just copy one of these, stick it in a frame, have a French name, and sell it to some stupid billionaire for millions? Because modern art is mostly a waste of time. Because I don't understand it. Yeah. It's fun. I mean, if you get one of these that's nice, shouldn't you print it and color it in? Because I think it would be just kind of cool. It's got lovely geometry to it. I think I love visual things, and this is just so visual. Okay, I've ranted on enough.
Modern art, one of the reasons why it's craft is because it doesn't need to be good. So art isn't taxed. So they can buy ridiculous, useless art that the appraisers just say is worth something, and then they can just use it to launder money. That's the main reason for modern art.
It really
It's
is. Yeah.
wild.
It's a huge money laundering thing. By the way, when we were doing the basic ones, like when you would have a number plus and then a number cos theta or whatever, does that move it up or down? I forgot I didn't write it down.
Are we talking about in sketching it?
Yeah, kind of like an A.
Yeah, I think they move them left, right, or up and down, depending if it's a sine or a cosine. So if you did 3 plus sine or 3 plus cosine, they'd be changing where it was. It would get moved left, right, up or down.
Okay.
Okay, last name, guys, and bye-bye for today.